Okay, let's talk today about the basic concepts on engineering. The stuff that actually underlines engineering, such as the basics. Okay, we're going to talk about what is the definition of work and power, what's the difference between the two, energy, force, torque. Okay, once we've got that covered, right, force. The most basic force, thought up by Mr. Isaac Newton. Okay, a force is a push or pull on an object resulting from its interaction with another object. Okay, so remember Newton's law that says an object will remain stationary or in motion unless acted upon by another force. Okay. Now in this case, force is done in newtons. Yeah? The unit of force is a newton. Okay. Now, in this case, the force here is at 45 degrees to the object. So as we'll get later on, we're going to see that we would then split that up into a vertical force and a horizontal force. Okay. The equation for force equals mass times acceleration. Okay. Newton's second law of motion. Okay, so the newtons is the mass in kilograms. Now remember, a mass in this case is not the weight of a material. Right? An object has weight because we take the mass and add gravity to it. Okay? If we're talking about mass, then a kilogram of mass on Earth would be the same as a kilogram of mass on the moon, even though the moon's gravity is 1/6 of Earth's. Okay? The actual physical makeup or the solid of whatever it is we're looking at, that's its mass. Okay? So force is mass times acceleration. Okay? To move something, how much force do we have to apply to it to get that mass to accelerate at a particular speed? Okay. Now, if we then take that force and use it to move an object over a distance, that's defined as doing work. Okay. So when a body moves under the influence of a force, work is done. So therefore the equation is work is equal to the force times the distance. Okay? And the unit for that is joules. So newtons times millimeters equals a joule, or newtons times kilometers, if you like, equals a joule. Okay. Adding on to that, let's talk about energy. Also, the unit of energy is joules. Okay? It's broadly defined as the ability to do work. In other words, that's the force, if you like, applied to a mass to allow us to do the work. Okay. Now, it's a funny thing. Energy is all around us, and the energy that's created is never, you can't create or destroy energy. All we can do is convert energy from one form to another. Okay. Now, think about it. If we dig up fuel from the ground, that fuel has built-in energy in that by setting fire to the fuel, we release heat. So we've converted internal energy of, say, a pint of petrol into heat. Okay, we haven't lost it, we've just converted it. So something to bear in mind is that energy is never created or destroyed, it's only ever changed. Okay, so we can convert what we call potential energy into kinetic energy. I'll cover those two terms just now. Okay. Potential energy is energy stored in a system, typically due to its height or to an internal source such as a compressed spring, a pressurized vessel, chemical, i.e. we can burn it, okay, or we're maintaining heat inside, okay. All that energy is stored and it has the potential to do work. Okay, now, as I say, one of the big ways of potential energy is its height above a reference point. The higher up you take something, the more potential energy you're giving it. Think about it. If you drop your cell phone 3 or 4 inches, chances are there's not too much damage. If you drop it from the top of your house, you're going to do a lot of damage. The only difference was the height and the potential energy for doing damage to your cell phones. Okay. Now the other type of energy we look at is kinetic energy. That is the energy possessed by a body, in other words, a mass, by virtue of its motion. Okay. In other words, kinetic energy is given by speed. Okay. The faster a body is moving, the more kinetic energy it has. Okay. And the more potential there is for that energy to be converted into a different type of energy. Okay. So that's the two main ones: potential energy and kinetic energy. Okay. Now, to work out what our potential is, obviously we said it's about the gravitational force. So potential energy is your mass times the height of the object above the datum times gravity. Okay. Those three together give you the potential energy in a system or of an object. Okay. Kinetic energy, we said, is the speed that gives it the energy. So therefore, you're going to expect velocity to be involved. Okay, so it's half times the mass times the velocity squared will allow us to work out our kinetic energy. So when the velocity is 0, the kinetic energy is also 0. Okay. Fairly simple basics, but without these, when we start talking about other parts later on in the course, we need to understand what's happening here. Now, going back to power. We said power was the rate of doing work. Okay? It's measured in terms of the amount of work done in 1 second. Right? Work was a force times the distance, remember? So if we then take that force, right, over a distance, and then we look at the average velocity, how fast we moved across the distance, that now gives us our power. Right? And the unit of power is watts. Right? How much work is done by a mass moving through a certain distance in a certain time. Okay. So power then is the rate of doing work. Right? Now, another term we're going to be using several times is that of torque. So we need to understand what that's all about. Okay? Torque is the rotational force applied to an object. Okay? And it's done normally in Newton meters or sometimes in kilogram force per meters. All right? Now, the torque, we're talking here about the potential to turn this bolt. Okay? In this case, if I've got a 1 meter long spanner and I apply 10 kilograms of force to the end of that spanner, that gives me 10 kilograms per meter of torque. Okay? That means 10 kilograms per meter of rotational energy at the center point here. Okay, so torque is designed to cause rotation around a central point. And its units are kilogram meters. Okay. If you think of a car engine, torque is what accelerates the car. Okay, the rotational force, and power is what gives the car its top speed. Okay. So, what is the equation for power? Is it A, B, C, or D? B. Well done, Nigel. Power equals force times velocity.